Hi there, and welcome to this lesson. Now, in this lesson, we're learning about linear equations, okay? And under linear equations, we'll be learning change of subject formula. Very interesting. So, at this point, I remind you to set the video to play in 1080p HD. Very important that you do so. And as the lesson progresses, if you have any issues at all, anything comes up as unclear, please feel free to get in touch. We would be more than happy to help. Okay, let's jump right into the lesson. So linear equations, change of subject formula. Now, what exactly is change of subject formula? So I have this circle here, okay? And then basically this circle has a radius r. Now, if we were looking to find the area of this circle, the area A, basically we all know that the area of a circle is pi r squared. Okay, now, what if we had an instance where we had the area of the circle? Okay, so we're given the area, and then we're asked to find the radius. How do we find the radius? Now, basically, we would have to reverse that formula. So we know that area is pi r squared. We would have to reverse that formula to give us radius in terms of A. Okay, so how do we go about doing this? And what this is, it's basically making r the subject of formula in the formula A equals pi r squared. So we want to rearrange this formula such that we have r equals something. Now, how do we go about doing that? It's actually very similar to solving linear equations. Okay, and basically just like we do in basic simple linear equations, we're looking to get r on the left and everything else on the right. The only difference is we usually don't have numbers at play. We'll sometimes have numbers, but we usually don't have numbers at play because it is a formula. So we're looking to get r on the left and everything else on the right. How do we go about doing this? So the first thing we have a something multiplying r. We actually have r squared, but then we have something multiplying r, and we need to get rid of that to start with. And what we do, we have pi multiplying r, and we're going to divide both sides by pi. Okay, and when we do that, what we have is we have that a over pi, because pi would cancel pi on the right, we have that a over pi equals r squared. Now, if we have a over pi equals r squared and we're looking to find r, how do we go about doing that? We can actually find the square root of both sides, because the square root of r squared is r. So if you find the square root of r squared, you would end up with r, and you basically do exactly the same on the left. So you find the square root of both sides, just like you would divide by both sides to eliminate a coefficient. Basically, we find the square root of both sides to eliminate a square. Sometimes you could be given a square root on both you could have a situation where you're looking to eliminate a square root, and what you do in that situation is you basically square both sides. But in this case, we have a square and we're looking to eliminate that square. So what we do is we find the square root of both sides, and you have that the square root of r squared is r, okay, and basically the square root of a over pi is square root of a over pi. So we basically have r equals square root of a over pi, and that's it. Basically, if you're given the area of a circle and you're looking to find the radius of that circle, you can actually put your area into this formula, okay, the square root of a over pi, and you would end up with the radius of that circle. And that is what change of subject formula is about. It's pretty much simple linear equations, but in this case we're not working with numbers, we're actually working with other variables. Let's do a few examples. So example 1. And example 1 says make f the subject of formula in the relation v equals u plus ft. So we have a formula here, okay, for v, and basically we assume we're given v, we're given u, we're given t, and we're looking to find f. So what we want to do is we want to reverse this formula, okay, to make f the subject of the formula. At the moment, v is the subject of formula. We want to rearrange this formula so that f is the subject of formula. Now, how do we go about doing that? basically, like I said, you're pretty much solving a linear equation. So you have that v equals u plus ft. Okay, so we have we're looking to get f on the left, okay, and everything else on the right. So the first thing we want to do is we want to get rid of u. Okay, so we move u over to the, we move u across the equal sign, and basically we have that ft equals v minus u. Okay, now we have ft equals v minus u. I think at this point it is safe to say that we can go ahead and divide both sides by t. So ft equals v minus u. Okay, we divide both sides by t, and we would end up with f equals v minus u over t, and that is it. We now have that we now have f as our subject of formula. Now let's do another example. So example 2. And example 2 says if p equals the third root of q r minus t over 15, make t the subject of formula. Interesting. So what we want to do here, basically, like you would do for a linear equation, you're pretty much looking to get t on the left and everything else on the right. Okay, and you have p equals the third root of q multiplying r minus t over 15. The first thing we need to do here is we need to get rid of that third root. Okay, and like I said, when you're looking to get rid of a square root of it, or if you're looking to get rid of a square root, you square. Okay, now if you're looking to get rid of a third root, you raise both sides to the power of 3. Okay, so you have that p cubed equals the third root of everything that you have there, all cubed. Now when you do that, what you have is you have p cubed equals q multiplying r minus t over 15, and now we have gotten rid of our third root. Now the next thing we want to do, basically we have that p equals q multiplying r minus t over 15. I'm going to expand the expression we have at the top there. Okay, so I have p cubed equals qr minus qt over 15. Okay, and then I'd cross multiply. Okay, and I have 15p cubed equals qr minus qt. It's getting very interesting now. Okay, so we have a very straight equation here. Okay, and then now we're looking to get t on its own and everything else on the other side. So I can move qr over to the left, okay, or basically move qt over to the left and 15p cubed over to the right, and what I end up with is I have qt equals qr minus 15p cubed. Okay, so looking to get t alone on the left and everything else on the right. What I'm going to do now is I'm going to divide. We have q multiplying t, so I'm going to divide both sides by q. Okay, and what I have as my final answer is t equals qr minus 15p cubed over q, and that is your formula with t as the subject. Okay, so we've rearranged this formula and we now have t as our subject or formula. It's actually really easy. It's pretty much just solving a simple linear equation. Now another example, example 3. And example 3 says if k equals mn over xa plus n, make n the subject of formula. Now this one is actually very, very interesting. Reason being, we actually have two n's in our equation there. Okay, so which n do we make the subject of formula? That's a very, very interesting question. Which of the n's, because we have n at the top, okay, we have mn, and we also have another n at the bottom, so which of the n's do we make the subject of formula? Okay, so there is a very, 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 very simple way of getting this done. Okay, and we'll find out shortly. Factorization actually comes in very, very handy here. Okay, but first of all, let's do what we have to do. Okay, let's simplify. So basically the first thing we want to do is we expand what we have at the bottom there. So we have that k equals mn over ax plus xn. Okay, And then the next thing we want to do is we want to cross multiply. So we have k multiplying ax plus xn equals mn. Okay, and then after that we want to expand what we have up there. So we have kax plus kxn equals mn. Okay, and now this is where it gets interesting. Because we're looking to make n the subject of formula, we're going to get all the n's together. Okay, we're going to get every term that contains n on the left and everything else on the right. So we have kxn and mn. We want to work this equation, okay, to get kxn and mn on the left, okay, and kax on the right. So we move our terms around, okay. Remember, the sign changes when you move something across the equal sign, and what we end up with is we have mn minus kxn equals kax. Now what do we do here? We factorize. Okay, now watch this. I'm going to factorize using n, okay, and basically when I factorize using n, I have m minus kx equals kax. Now if you notice, we now have one n in the equation, okay. So factorization has pretty much simplified things for us. So if you ever faced with an equation like this or formula like this where you have two of the same variable, okay, and you're told to make that variable the subject of formula, you basically work to get every term containing that variable to the left, okay, to the left of the equal sign, and then you factorize. And once you factorize using that variable, you pretty much end up with just one of that variable. So we have n multiplying m minus kx equals kax, okay, and from this point on I can actually divide, because we have m minus kx multiplying n and we're looking to get n on its own, so I can divide both sides by m minus kx, okay, and basically when I do that, we have m minus kx cancelling on the left, and what we're left with is n equals kax over m minus kx, and that is how you make n the subject of formula in the relation k equals mn over x plus a plus over x multiplying a plus n. So actually very simple, okay, there really isn't much to it. Let's move on. Now example 4. And example 4 says if x over a plus 1 plus y plus b equals 1, okay, so we have a formula there, make y the subject of formula. So we have some fractions in play here, and yeah, let's get right into it. So we have x over a plus 1 plus y over b equals 1. Now we actually make y the subject of formula. Now when you're faced with an equation like this, okay, or formula like this, and you have your variable as in form of a fraction, okay, the first thing you want to do is you want to get the fraction containing your variable, okay, i.e. the fraction containing y, on one side and everything else on the other side, okay. So I'm going to have y over b equals x over a plus 1 plus 1, okay. That's the first thing I'm going to do here. Now the next thing I want to do is I want to solve the fraction on the right, okay. So y over b equals x over a plus 1 plus 1. I want to solve everything that I have on the right, because basically to have this as one fraction. So I have y over b equals, okay, bring in a common denominator, a plus 1, and basically what you have is you have x plus a plus 1, okay, because when you do a plus 1 divided by a plus 1 is 1, multiplied by x, you have x, okay, and then you have a plus 1 divided by 1, basically the fraction we have there is 1 over 1, so you have a plus 1 divided by 1 multiplied by 1, and you have a plus 1, giving you x plus a plus 1. So we now have y over b equals x plus a plus 1 over a plus 1. So we have two fractions in play now, and at the moment we can actually go ahead and just cross multiply, okay, and basically we have y multiplying a plus 1 equals b multiplying x plus a plus 1, okay, and then To get rid of a plus 1 on the left, we can divide both sides by a plus 1. Okay, and when we do that, we end up with y equals b multiplying x plus a plus 1 over a plus 1, and that is it. Basically, you have y as your subject or formula in the relation. Very simple, very straightforward. Let's move on to the next example. So this is our final example, example 5. Okay, and we have more fractions in play here. So we have 1 over u plus 1 over v equals 1 over f, and we've been asked to make v the subject of formula. Okay, how do we go about doing this? So remember, the first thing we want to do is we want to get our fraction containing our variable, so i.e. 1 over v over to the left and everything else to the right. Okay, so you have 1 over v equals 1 over f minus 1 over u. Now, once we've done that, we'll then solve the fractions on the right. So I have that 1 over v equals, a common denominator here would be uf, okay? And basically I have uf divided by f multiplied by 1. I have u minus uf divided by u multiplied by 1 would give me f. And basically what I have is 1 over v equals 1 over v equals u minus f over uf. Now, from this point, I can actually just flip, because I have that 1 over v equals u minus f over uf. To get v, I can actually just flip the fractions, both fractions on both sides. So I have v over 1 equals uf over u minus f. And that's it. Very simple. You have v as your subject of formula. So it's been a very interesting lesson. Okay, the subject of formula, pretty much the same as solving a linear equation. There really isn't a difference, to be fair. And yeah, bye for now.